In this lesson, we're going to talk about different ways in which we can calculate the molarity. But this first example is a very straightforward example. So we're given 15 grams of sodium bromide in 400 milliliters of solution. Now here's the formula you need to calculate the molarity of the solution. The molarity of the solution is the moles of solute divided by the liters of the solution. So we have 15 grams of sodium bromide. Sodium bromide is the solute. Water is the solvent. So the solute plus the solvent adds up to make the solution. We need to convert grams to moles. So we need the molar mass. The atomic mass of sodium is 23, and the atomic mass of bromine is 79.9. And so that adds up to 102.9. So 1 mole of NaBr has a mass of 102.9 grams. Now what we need is to convert milliliters into liters. So we have 400 milliliters of solution, and 1 liter is equal to 1,000 milliliters. So we're going to divide 400 by 1,000, and that's going to give us 0.4 liters. So right now we have the moles of the solute. All we need to do is divide it by the liters of the solution. So moles over liters will give us the unit for molarity, represented by capital M. So it's 15 divided by 102.9, and so we have 0.1458 moles of sodium bromide divided by 0.4 liters. So that will give us a molarity of 0.364. moles per liter. So this is the answer to the problem. Now let's move on to number 2. The mass percent of aluminum chloride in water is 15%. The density of the solution is 1.17 grams per milliliter. What is the molarity of the solution? So if you want to try this problem, you can stop the video and work it out, see if you can get the answer. So how can we find the molarity given the mass percent and the density of the solution? Now, the mass percent tells us the ratio between the mass of the solute and the mass of the solution. So this is the formula for mass percent. Now keep in mind, the solute plus the solvent always adds up to the solution. The solute in this case is aluminum chloride, AlCl3. Water is a solvent. Water dissolves AlCl3. So if we have a 15% mass percent, then that means that there's 15 grams of solute per 100 grams of solution, because 15 over 100 times 100 is a 15%. 100 minus 15 is 85. So that means that we have 85 grams of water. So with this information, can you figure out the rest of the problem? Now what we need to do is we need to find the moles of the solute, which we can easily do because we have the mass of the solute, and we need to find the liters of the solution. Now we have the grams of the solution and we have the density. Those two combined can help us to get the milliliters of the solution. So let's start with 100 grams of solution. And if the density is 1.17 grams per milliliter, what that means is that 1 milliliter of solution has 1.17 grams. So now the next thing we need to do is convert milliliters into liters. And 1 liter is 1,000 milliliters. So now we have the volume of the solution in liters. So it's 100 divided by 1.17, and then divide that result by 1,000. So it's 0.08547 liters. Now let's start with 15 grams of aluminum chloride, and let's convert it to moles. So first we need to get the molar mass of AlCl3. So we have 1 aluminum atom and 3 chlorine atoms. So aluminum is 26.98 based on the periodic table, and chlorine is 35.45. So this adds up to 133.33 grams per mole. So now let's convert grams to moles. So this will give us the moles of AlCl3. Now the last thing we need to do is divide the moles by the liters. And this should give us the molarity of the solution. So it's 15 divided by 133.33, and then take that result, divide by 0.08547. And so the molarity of the solution is about 1.32. And so that's it for this problem. That's how you can calculate the molarity of the solution given the mass percent and the density of the solution. Number 3. What is the molarity of a 1.25 molal glucose aqueous solution with a density of 1.09 grams per milliliter? Now granted, this could be fructose, but it has the same chemical formula as glucose. So how can we find the molarity given the molality and the density of the solution? So what do you think we need to do? How can we do this? Well, let's focus on the molality. A 1.25 molal solution means that there's 1.25 moles of glucose per 1 kilogram of solvent. In this case, it's an aqueous solution, so the solvent is water. Now, it might be good to choose a certain mass of water. Now, it really doesn't matter how many grams of water you choose. It could be 100 grams, 200 grams, 1 kilogram. But I'm going to choose 1 kilogram because if I have 1 kilogram of water, then I know how many moles of solute I have, 1.25 moles. And that's half the battle. The last thing I need to find is just the liters of the solution, and then I can find the molarity. So I'm going to make this statement. So for an aqueous solution that contains 1 kilogram of water, there's going to be 1.25 moles of glucose or solute. And with this information, I can now find the volume of the solution. Now I have the density of the solution, which relates the grams of the solution to the milliliters of the solution. So I need to find the mass of the solution. And using mass and density, I could find the volume of the solution. Now keep in mind, the solute plus the solvent adds up to the solution. I already have the mass of the solvent. 1 kilograms of water is 1,000 grams of water. So now I need to find the mass of the solute and then add those two together to get the mass of the solution. So I have the moles of the solute, 1.25 moles. All I need to do is convert it to grams. So let's find the molar mass of glucose. The atomic mass of carbon is 12.01, and we need to multiply it by 6. Hydrogen is 1.008, and the atomic mass of oxygen is 16. So the molar mass of glucose is 180.156. So 1 mole of glucose has a mass of 180.156 grams. Now let's multiply that by 1.25. And so the mass of the solute is 225.195 grams. And let's add 1,000 to that. So that's going to be 1225.195 grams of solution. So now we could find the volume of the solution. So let's start with the mass of the solution, and let's divide it by the density. Now set it up in such a way that the unit grams will cancel. Now let's convert milliliters into liters. So there's 1,000 milliliters per liter. So this is going to be 1225.195 divided by 1.09 divided by 1,000. So the volume of the solution is 1.124 liters. So now to calculate the molarity, we need to take the moles of the solute and divide it by the liters of the solution. So the molarity is going to be 1.25 divided by 1.124 liters. And so the molarity of the solution is 1.112 m. And so this is the final answer. That's how you can calculate the molarity of the solution given the molality and the density of the solution.